Your brain is shrinking right now, not metaphorically, not as a figure of speech, literally, measurably shrinking. And after 60, it happens every single year, whether you feel it or not. Now, before you close this video, I need you to hear the second half of that sentence. Because the first half is what most doctors tell you, usually without context, usually without explanation, and almost always without telling you what comes next. What comes next is this. This process can be slowed down. And in specific, documented, measurable ways, it can be partially reversed. I have MRI data to prove it. Real scans, real numbers. A landmark study published in one of the most prestigious scientific journals in the world, and I'm going to walk you through every number in it today. But here's what really frustrates me, and I say this as someone who has spent years reviewing this literature. This research has been sitting in peer-reviewed journals since 2011, 13 years. And the vast majority of people over 60 who are quietly terrified every time they forget a name, lose a word mid-sentence, or walk into a room and can't remember why they went there, those people have never been told any of this. That ends today. Have you ever had a moment where you forgot something so simple that it genuinely scared you, and you didn't tell anyone because you were afraid of what it might mean? Drop that in the comments, because I promise you, you are not alone. Not even close. Hi, I'm Dr. Marcus Cole. I'm a neuroscience communicator, and I've spent years studying the aging brain, specifically how the brain changes structurally after 60, and what the peer-reviewed science actually says about slowing and reversing that process. And let me be upfront with you from the very beginning. What I'm going to show you today is not a supplement pitch. It's not a miracle protocol. It's not a promise that you'll have the memory of a 30-year-old by next Tuesday. What it is the actual neuroscience, the actual study, the actual numbers, and a 3-layer protocol that real people used in a real clinical trial and produced real measurable changes on MRI scans. Here is exactly what we're covering today. First, what is actually happening inside your brain after 60? The anatomy, the timeline, the specific region that's most at risk, and why most people confuse normal aging with something far more serious. Second, the landmark study that changed everything we thought we knew about the aging brain. I'm going to walk you through every number. Third, the mechanism behind why this works. A molecule called BDNF, and once you understand what it does, you're going to look at your daily habits very differently. And fourth, the exact 3-layer protocol. Movement, nutrition, sleep, what the research actually used, how much, how often, and what to realistically expect, and when. Before we go further, if you've never had a doctor sit down and explain what is actually happening structurally inside your brain as you age, that is exactly what this channel is here for. Every video is built on real science, peer-reviewed studies, no fluff, no sensationalism. If that's what you're looking for, hit subscribe. Takes 2 seconds, and it means this information gets to more people who genuinely need it. All right, let's talk about what's actually going on in there. Here's the number I want you to hold on to for this entire video, 0.5%. After the age of 60, the human brain loses approximately 0.5% of its volume every single year. Now, 0.5% sounds small. I get it. It doesn't sound alarming on its own. So let me put it in terms that make the math very concrete. By the time you're 70, that's 5% of your brain volume gone. By 80, that's 10%. And this isn't distributed evenly across the brain. It concentrates in a very specific area. An area that, not coincidentally, is the exact region responsible for the things you've probably already noticed getting harder. That area is called the hippocampus. The hippocampus, and I want you to picture this clearly, is a small seahorse-shaped structure sitting deep in the center of your brain, one on each side. It is the brain's memory hub, its filing system, the region responsible for forming new memories, retrieving old ones, learning new information, and navigating through space, which is why getting disoriented in familiar places is often one of the early signs people notice. In simple terms, if your brain were a smartphone, the hippocampus is where your photos are stored, where your contacts live, and where the GPS runs. When it shrinks, those functions degrade, not dramatically at first, but measurably, consistently, year after year. And in sedentary adults over 60, meaning people who are not doing specific things to counter this process, the hippocampus loses volume at a rate that researchers can measure directly using MRI. Think of it like this. Imagine a garden that you've spent decades building. Flowers, trees, paths you know by heart. Now imagine what happens if you stop watering it. Not all at once, but slowly, gradually, season after season. The plants don't die overnight, but year by year, things you once knew exactly where to find begin to feel harder to reach. That's not a perfect analogy, but it's close enough to the biology to be useful. That's why names start taking longer to come back. That's why words that used to arrive instantly now sit on the tip of your tongue for seconds that feel like minutes. That's not a character flaw. That's a biological process with a name, a mechanism, and this is the critical part, a documented intervention. Now, before I show you the study, I want to explain what's accelerating this process, because understanding what's working against your hippocampus is what makes the protocol make sense. There are three main accelerators of hippocampal atrophy in adults over 60. And I'll be honest with you, when I first mapped these three together and looked at how they interact, I had to go back and recheck the literature twice, because they don't just add up, they multiply each other. The first one is chronic cortisol. Cortisol is your stress hormone, and in short bursts, it's essential. It keeps you alert, helps you respond to challenges, gets you through difficult moments. That's what it's designed for. The problem is when it's chronically elevated, when your nervous system is running a low-grade stress response day after day, month after month. In that state, cortisol directly inhibits hippocampal neurogenesis, meaning it actively suppresses the brain's ability to grow new neurons in the very region we're talking about. Studies measuring cortisol levels and hippocampal volume in adults over 60 consistently find an inverse relationship. The higher the chronic cortisol, the smaller the hippocampus. The second accelerator is sedentariness. And I want to be specific here because this is where the data gets both sobering and, once you understand the mechanism, actually quite empowering. Physical inactivity reduces BDNF, a molecule I'm going to explain in detail shortly, by up to 30% in adults over 60. 30%. That's not a rounding error. That's the difference between that is maintaining its architecture and one that is gradually losing the molecular signal it needs to do so. The third accelerator is sleep disruption. And this one surprises people most. A single night of poor sleep, just one, reduces the hippocampus's ability to consolidate new memories by approximately 40%. A 2022 review by Lucassen and colleagues, published in Current Topics in Behavioral Neurosciences, documented the relationship between slow-wave sleep, the deep restorative stage, and hippocampal neurogenesis. Without adequate slow-wave sleep, the hippocampus is essentially operating without its overnight maintenance cycle. These three, chronic stress, sedentariness, and sleep disruption, don't just work in parallel. They feed each other. Poor sleep raises cortisol. Elevated cortisol disrupts sleep architecture. Sedentariness reduces the molecular signal that buffers both. It is a loop, and it accelerates with each decade after 60. But here's the thing about loops. They can run in reverse. Before I show you the study, I want to pause here for a moment. Because if what I've described so far resonates with you, if you've been noticing these changes, living with this quiet fear, and never quite knowing what was actually happening or what to actually do about it, I want you to know that this video covers the essential foundation. But a foundation is not a complete system. The 30-day brain reset system was built for exactly this, for people who want more than one video's worth of information. For people who want the full protocol, mapped day by day, built on the same peer-reviewed science I'm walking you through right now. Here is what's inside. Your doctor never told you that chronic stress is physically shrinking your brain, that poor sleep is failing to clear the proteins linked to Alzheimer's, that the food you eat is either rebuilding your neurons or slowly destroying them. They never told you because nobody taught them the neuroscience. But it exists. It's published in Harvard, Nature, JAMA, and Stanford, and it changes everything. The 30-day brain reset system translates that science into 10 complete protocols. The full 30-day neurological reset, mapped day by day. The Alzheimer's Defense Protocol, covering the 12 modifiable risk factors that science has identified. The Brain Food Bible, 47 foods ranked by neuroscience with every dose explained. And the Sleep Optimization Protocol, because what I'm about to tell you about slow-wave sleep and your hippocampus makes this the most underrated intervention in brain health. Every protocol, every study, every DOI link, no guesswork, no false promises. Your brain can rebuild what time and stress have taken. Not completely, I'll never tell you that, but measurably, documentably, in ways that show up on MRI scans. The link is in the description. Take a look after the video. Now, let's get to the study. Because this is where everything changes. In 2011, researchers at the University of Pittsburgh published a study in the Proceedings of the National Academy of Sciences, one of the most prestigious scientific journals in the world. Lead author, Dr. Kirk Erickson. And the results were significant enough that they made neuroscientists genuinely reconsider something that had been treated as settled science for decades. Here is exactly what they did. 120 adults between the ages of 55 and 80 were divided into two groups. Group 1 began a program of moderate aerobic exercise, walking. Group 2 did stretching and toning exercises, low-intensity activities that don't significantly elevate heart rate. Both groups followed their respective programs for 12 months. At the beginning and end of the study, every participant received an MRI scan measuring hippocampal volume with precision. Here are the numbers. After 12 months, the aerobic exercise group showed a 2% increase in hippocampal volume, 2%, measured directly on MRI. The stretching group, the control group, lost 1.4% of hippocampal volume over the same period. The total difference between the two groups, 3.4%. And the researchers calculated that this increase was equivalent to reversing 1 to 2 years of age-related atrophy. Let me say that one more time clearly, because I want this to land properly. People who walked moderately consistently for 1 year didn't just slow down the shrinking of their memory center. They grew it back, partially, measurably, on an MRI. And on top of the volumetric data, the aerobic exercise group showed 15 to 20% improvements on standardized spatial memory tests compared to the control group. This is not a supplement study. This is not a small pilot. This is 120 people, 12 months, one of the world's top research institutions, published in one of the world's most rigorous peer-reviewed journals. I genuinely want to ask you something right now, and I want you to answer in the comments. Did your doctor ever tell you that exercise could literally grow your hippocampus? Yes or no? Because in my experience, the answer from most people over 60 is no. And that gap between what the science knows and what reaches patients is exactly why I make these videos. So why does aerobic exercise grow the hippocampus? What is the actual biological mechanism? Because understanding this is what takes the protocol from something you're doing on faith to something you're doing with full knowledge of what's happening inside your brain. The answer is a molecule called BDNF, brain-derived neurotrophic factor. Think of BDNF as fertilizer for your brain. Not a perfect analogy, but mechanically it's the closest one. BDNF is a protein produced in the brain and body that stimulates the growth and maintenance of neurons, promotes the formation of new synaptic connections, and protects existing neurons from damage and death. In the hippocampus specifically, BDNF is the molecular signal that drives neurogenesis, the actual creation of new neurons in adult brain tissue. Yes, new neurons. In adults, this was itself considered impossible before the mid-1990s. Aerobic exercise is the single most potent stimulus for BDNF production that has been documented in humans. More potent than any supplement, more potent than any meditation protocol tested. During and after moderate aerobic activity, BDNF levels in the bloodstream rise measurably, and this increase is directly correlated with hippocampal volume changes over time in the Erickson data and the 2018 meta-analysis by Firth and colleagues in NeuroImage, reviewing 22 studies across 1,478 participants. Sleep amplifies this. During slow-wave sleep, the deep sleep stage that most people over 60 don't get enough of, BDNF production peaks and the hippocampus consolidates the day's memories. Specific nutrition compounds, particularly the omega-3 DHA found in fatty fish and the anthocyanins in blueberries, amplify BDNF receptor sensitivity, meaning they help the brain respond more efficiently to the BDNF that exercise produces. That's the mechanism. That's the why behind the three-layer protocol. Movement produces the signal, sleep amplifies it, nutrition optimizes the response. And that's exactly what we're covering next. All right, let's get into the actual protocol. And I want to deliver this with the same precision the research used, because the details matter. And the details are also, and this is important, far more accessible than most people expect. Layer 1 is movement. And before I give you the specifics, let me reframe something that I think gets in the way for a lot of people over 60 when they hear the word exercise. Most people assume that if exercise is going to change their brain, it has to be intense, that they need to be running, sweating hard, pushing their limits. The Erickson study, the one with the MRI data we just discussed, used walking, moderate-paced walking, 150 minutes per week, distributed across 5 sessions of 30 minutes each. That is the dose. That is exactly what produced a 2% increase in hippocampal volume in adults up to 80 years old. Not a marathon, not a gym membership with heavy weights. 30 minutes of brisk walking, 5 days a week. Now, brisk walking means walking at a pace where you could hold a conversation, but you'd be slightly breathless doing it. Not strolling, not sprinting. The moderate aerobic zone, where your heart rate is elevated enough to trigger BDNF production, but not so elevated that you're working anaerobically. The 2018 meta-analysis by Firth and colleagues, reviewing 22 controlled studies with 1,478 older adults, confirmed this dose-response relationship. The minimum effective dose for measurable hippocampal effects was approximately 120 to 150 minutes per week of moderate aerobic activity. Below that threshold, effects were inconsistent. At and above that threshold, the data across studies was remarkably consistent. Swimming works, cycling works, dancing, which also adds a cognitive coordination component, shows some of the strongest data. What matters is that the heart rate is in the moderate aerobic zone and the activity is consistent across weeks and months. The hippocampus doesn't respond to one heroic week of exercise. It responds to the accumulated signal of consistent moderate effort over time. Here's a question I genuinely want you to answer in the comments. What's the one thing that has stopped you from being more physically active in the last year? Not judgment, real answer. Because the patterns that come up there always point to the actual barriers, not the ones we assume. Layer 2 is nutrition. And I want to be very specific here because I'm not going to give you a general eat healthy recommendation. The research has identified specific compounds in specific foods that directly influence BDNF signaling in the aging brain. 3 foods. That's where I want to focus. Not because they're the only ones that matter, but because these 3 have the strongest evidence base and are accessible to essentially everyone watching this. The first is blueberries. Wild blueberries specifically, though cultivated blueberries have overlapping benefits. Blueberries are dense in anthocyanins, a class of flavonoid compounds that cross the blood-brain barrier and directly amplify BDNF receptor sensitivity in hippocampal tissue. The 2015 study by Jaka and colleagues, published in BMC Medicine, examining diet quality and hippocampal volume in adults over 60, found that higher intake of flavonoid-rich foods was one of the strongest dietary predictors of preserved hippocampal volume independent of other lifestyle factors. Think of anthocyanins like a signal amplifier. The BDNF your exercise produces is the signal. The anthocyanins help your hippocampus receive that signal more efficiently, like improving the antenna on a radio that was picking up static. A half cup of blueberries 4 or more times per week is the frequency that appears across the strongest studies. The second food is wild-caught fatty fish, salmon being the most practical example. The active compound here is DHA, a specific omega-3 fatty acid that is literally a structural component of brain cell membranes. 30% of the brain's gray matter is composed of DHA. When DHA levels drop, which they do with age and with low fish intake, neuronal membrane flexibility decreases, BDNF signaling becomes less efficient, and hippocampal function degrades. 2 to 3 servings per week of wild-caught salmon is the minimum frequency supported by the literature. The third is extra virgin olive oil, specifically cold-pressed, high-quality olive oil, not the refined varieties. The active compound is oleocanthal, a phenolic compound with documented anti-inflammatory properties that specifically targets neuroinflammation, inflammation within brain tissue that accelerates hippocampal atrophy. 2 tablespoons of extra virgin olive oil daily, used as the primary cooking and dressing fat, is the dose used in the Mediterranean diet trials that showed hippocampal benefits. These 3 are not magic foods, but they are foods with a documented mechanism, a documented dose, and a documented effect on the specific brain region we're talking about. That is a different category from general nutritional advice, and that distinction matters. Layer 3 is sleep. And I want to spend real time on this one, because in my experience, sleep is the layer that people most consistently underestimate, and the research on sleep and the aging hippocampus is among the most striking I've encountered in this entire field. Here's the fundamental fact. The hippocampus does not just store memories during the day, it consolidates them at night, specifically during slow-wave sleep, also called deep sleep, the 3rd and 4th stages of the non-REM sleep cycle. During slow-wave sleep, the hippocampus replays the day's experiences, transfers information to long-term cortical storage, and undergoes the cellular maintenance processes, including BDNF-driven synaptic consolidation, that preserve its structure over time. When slow-wave sleep is insufficient, this process is incomplete. Memories encoded during the day are not fully transferred. BDNF production does not reach its nighttime peak, and the glymphatic system, the brain's waste clearance mechanism, which runs primarily during deep sleep and removes metabolic byproducts, including proteins associated with neurodegeneration, cannot complete its cycle. Now, here's where the practical protocol comes from. The research points to 3 specific interventions that meaningfully improve slow-wave sleep architecture in adults over 60. Not sleeping pills, because sleeping medication actually suppresses slow-wave sleep in most adults, meaning it helps you fall asleep, but does so at the cost of the most neurologically valuable stage. First, a consistent sleep and wake time, the same time, every day, including weekends. The brain's circadian rhythm governs the timing and depth of sleep stages, and irregular sleep timing disrupts slow-wave sleep disproportionately in aging adults. Second, bedroom temperature between 65 and 68 degrees Fahrenheit, 18 to 20 Celsius. Core body temperature drops during slow-wave sleep, and a cool room environment facilitates this drop. Adults who sleep in rooms above 70 degrees Fahrenheit consistently show reduced slow-wave sleep in sleep architecture studies. Third, eliminating screens 60 minutes before bed. Blue spectrum light from phones, tablets, and televisions suppresses melatonin production and delays sleep onset. But more critically, for our purposes, it fragments the slow-wave sleep stages that occur in the first half of the night, which is when hippocampal consolidation is most active. 7 to 9 hours in a cool, dark room at consistent times with screens off 60 minutes prior. That is the sleep protocol. Simple to state, genuinely difficult to maintain, but with one of the strongest evidence bases in brain aging research. Let me tell you exactly what to expect and when. Because one of the biggest reasons people abandon this protocol before it works is that they don't know what the early wins look like. They're waiting for the big result and missing the early signals. Weeks 1 and 2. You probably won't notice dramatic memory changes yet, and that's completely normal. What you will likely notice is improved sleep quality, specifically more consolidated sleep, fewer middle-of-the-night awakenings, and clearer energy in the morning. This is your BDNF beginning to rise. The neurological process has started. It's just not yet expressed in the cognitive metrics you're waiting for. This is real progress. Don't skip it. Weeks 3 through 8. This is when most people begin noticing the cognitive changes they were looking for. Word retrieval becomes faster. The tip of the tongue moments become less frequent. Short-term memory, remembering where you put things, recalling conversations from earlier in the day, shows measurable improvement. A 2014 study by Leckie and colleagues at the University of Pittsburgh, published in Frontiers in Human Neuroscience, following 65 adults over 60 through a 1-year exercise intervention, found measurable improvements in executive function tests beginning at the 8-week mark, well before the full structural changes were visible on imaging. Months 2 to 3, with consistent application of all 3 layers, movement, nutrition, and sleep, studies document gains in hippocampal volume measurable on MRI. The reversal is not complete. I will never tell you otherwise. The science doesn't support that, and your trust matters more to me than a headline. But a measurable, clinically significant, real reversal of 1 to 2 years of atrophy, documented, published, replicable, consistency at 80% is worth more than 2 perfect weeks followed by abandonment. Start with layer 1. Tomorrow morning, 30 minutes of walking. That is the entry point. That is where the BDNF begins. Get that right first, then add the nutrition layer, then optimize the sleep. Build it in sequence, and the compounding effect of all 3 layers together is what the studies were measuring. Screenshot the 3-layer protocol right now. Seriously, pause this video and take a screenshot of the infographic on screen. Because the research is very clear that people who write down or save a protocol are dramatically more likely to follow through on it than people who rely on memory alone. Which is a little ironic given what we've been talking about, but also completely supported by the behavioral science. Here's what I want you to do this week. Not this month, this week. Monday, 30 minutes of walking. That's it. That's the entire instruction for day 1. 1 decision, 1 action. The neuroscience starts there. If you want the complete system, the full 30-day protocol mapped day by day, the Alzheimer's Defense Protocol covering all 12 modifiable risk factors, the Brain Food Bible with 47 foods ranked by neuroscience and every dose explained, and the Sleep Optimization Protocol that expands everything I covered in Layer 3 today. The 30-day Brain Reset System is in the description. 10 complete protocols, every study cited, every DOI linked, built on Harvard, Nature, JAMA, and Stanford research. No guesswork, no false promises. Your brain grew new neurons today, just by learning something new. That is literal neuroscience. Learning stimulates BDNF. This video was, technically speaking, a cognitive workout. Now give that BDNF something to work with. Before I go, one last question, and this one I really want you to answer. What is one memory you are afraid of losing? It doesn't have to be specific. It can be a category, a person, a feeling, a chapter of your life. Drop it in the comments. Not because I can protect it for you, but because naming what matters is the first step toward protecting it. And if someone you love is over 60 and quietly worried about their memory, send them this video, not as a warning, as a gift, because the science says it's not too late and they deserve to know that. I'll see you in the next one. Dr. Cole out.